Hi guys, welcome back to another lesson on aptitude, and in this lesson we are discussing the critical concept of variations as an extension to the ratio proportion chapter, which we have already seen some lessons on in the previous videos of this chapter. Variations, as you know, is an important structuring or an important concept in mathematics. And essentially, when you try to understand variations, you first need to understand the three kinds of variations, or the three types of variations that happen. First, and second is you also need to understand some standard questions which are asked on variations, right? So let me first give you a brief into the basic concepts of variations. The first concept of variation is essentially the first type of variation is essentially what can be described as the direct variation. Now, when you talk about direct variation, you have a statement which might say x varies directly as y, or this can also be mentioned as x is directly proportional to y. In both scenarios, the mathematical writing of this, or the mathematical notation for this, x varies as y, is shown in this form. Now, when you think about a variation like x varies as y, it essentially means 4-5 things mathematically. The first one is, of course, logically. Logically, it means that if x increases, y will also increase, and if x decreases, y would also decrease. But this, of course, is a logical view of variations. You can also have what can be described as some parallel views on variations or numerical views on variations. So when we are talking about an x varies as y situation, it also means that if x is increasing by a certain percentage, let's say x is increasing by 20%, in that scenario, y would also increase by 20%. This is the percentage logic, or the percentage increase-decrease logic of variations. And of course, you can also think about the same thing in a ratio form, that if x is increasing by 1/5, y will also increase by 1/5. This is a relationship that will always hold. Both these relationships, of course, are talking about the same thing. And this is a relationship that will always hold for any x varies as y situation. You can also think about increasing by 1/5 also means that x is getting multiplied by 6/5, because when you multiply a number by 6/5, it also means that you're increasing the number by 1/5. And hence, you can also think of, if x varies as y and you are using a multiplier of 6/5 on x, you will use a multiplier of 6/5 on y also. If you're using a multiplier of 3/7 on x, the multiplier on y will also be 3/7. This is the third dimension, or the third view of direct variation. The fourth view is, of course, the ratio view, where you say that if you have two instances of x, x1, x2, and you take the ratio of those two instances, the parallel instances of the value of y, which can be described as y1, y2, will be equal. The ratio y1, y2 will be equal to the ratio x1 by x2 if you measure x in two instances and y in two instances. So this is where you can directly transfer the ratio of x to y and y to x if x is directly proportional to y, or x varies as y. And of course, the standard operation in x varies as y situation is that you can convert this into an equation. This gets converted to an equation if you use an x is equal to ky by introducing a constant k into this variation, you can convert the variation into an equation. And this is what the first kind of variation means, direct variation or direct proportion, right? X is directly proportional to y or x varies is y. These are the meanings that you can see of what we mean by x varies is y. The second variation that you come across or the second proportion you come across is where you say x is inversely proportional to y. X is inversely proportional to y, which also means x varies inversely as y, and this can also be written as the product of x into y is constant. All these three things mean the same thing, and mathematically it is expressed as x varies as 1 by y. X varies inversely as y is written as x varies as 1 by y. And please remember that the product constancy of x into y, and we have seen product constancy in the percentage chapter extensively, also means that x varies is 1 by y. It means the same thing, right? So there are three languages through which you can communicate. In a maths question, there are three languages through which you can communicate inverse variation. So when you're talking about x varies 1 by y, again, logically it means that if x is increasing, y is decreasing. If x is decreasing, y would be increasing. This is the logical meaning of this. But in percentage terms, if x is increasing by 25%, or in ratio terms, if x is increasing by 1/4, then y would be decreasing by 20%. All the product constancy values for percentages and fractions would hold true here. X is increasing by 1/4, y will be decreasing by 1/5. So this is how this would work. The logical part, the percentage part, or the ratio fraction increase decrease part, and of course if you think about this as a multiplier, if you increase a number by 1/4, it means you're making that number or you're multiplying that number by 5/4, and consequently if you're reducing a parallel number by 1/5, so let's say this was x, so x is getting multiplied by 1/4. So if y is reducing by 1/5, reducing a number by 1/5 means multiplying by 4/5. So whatever you multiply x by, the reciprocal of that will be the multiplier for y in such situations. And of course you can also create an x is equal to k by y by introducing constant. You can convert this into an equation. And the last but not least is that if you measure two instances of x, x1 by x2, then these would be equal to y2 by y1, because as you know, product constancy tells us that x1 y1 will be equal to x2 y2 and so on. So that's why you have to invert the ratio of x to get the ratio of y. So this is what inverse variation means. And the third kind of variation is what can be described as joint variation. Now, what we mean by joint variation is that if x varies jointly as y and z, it basically means that x is equal to, or x varies as y into z, and the reaction to this equation wise is x is equal to k y into z. So this is one part of it. And the second part, or the second way in which joint variation can be written, is if you say x varies as y when z is constant and x varies as z when y is constant. This also means x varies as y into z. So we'll be looking at some questions and some structures of thinking on these aspects in the following lessons, and we'll also look at some standard questions on variations in the following lessons. And for the time being, just review this and make sure that you understand the three ways or the three variations, and make sure you understand the ways in which you want to write those variations. So whenever you see any of these languages that I showed you, you should either conclude that we have a direct variation or an inverse variation or a joint variation in a problem, right? So we'll come back to you with the next lesson on the other side. Bye for now.